Hey, good morning, class, AP Physics class. This is Mr. Bean. Good morning. Today, we're going to discuss a video about lesson 8.6. This is the resistance lab. Here it is. Read you the theory. Resistance is a functional property of an object that describes its ability to impede or stop electron flow or flow of charge through it. Units of resistance are ohm, with this symbol here. For any given temperature, you can calculate an object's electrical resistance in ohms by using the formula R, which is resistance, and this funky looking P here is called resistivity. It's called rho. L is the length of a wire, and A is the cross-sectional area of the wire. So we have like a wire, like let's say this is a wire right here. We have the length of the wire, the type of wire it is, and also this cross-sectional area as well. So all this plays a role in the resistance or resistivity or resistance of an object. And down here is some more reading about it. Now here's a table at 20 degrees Celsius of various materials. Aluminum, copper, here's silver, nichrome, AU is gold, nichrome, Ag is silver, and W is wolfram or tungsten. And it tells you the resistivity range here of the material. Now this resistivity here is rho. So let's go back over here. This is rho right here. Let me highlight that and let's make it yellow. So this rho is what's found here in the table. So this is resistivity. In fact, let me go ahead and put in rho into this table here so we can see it better. Okay. And all right, there we go. So that's rho, and it has various ranges here. Okay. And this is at 20 degrees Celsius. It's beyond the scope of this class, but temperature does affect resistive or the resistance of materials. All right, so down here is some more information here, and also the material, the type of material you have and the shape it's in also affects resistivity or conductivity, which is the flow of electrons. Now, here's a visual demonstration that we'll go ahead and use here to help us maybe visualize it better. And let me kind of pull it off to the side here, like so. Okay, and so R is resistance. It's based on resistivity, the length, and also the cross-sectional area. So right now, this has a resistance of, let's say, 0.66 ohms. Now, if I change to different materials, we can see that as resistivity increases, as does resistance, and this can affect it. Okay, let's go back. We'll leave it at 0.8. Now, the length of the wire. So here's the length here. If I increase the length here, we can also increase resistance as well. If I reduce the resistance, much better. Okay, let's go back to 0.8. Now, that's why when you're doing electronics, you want to have the least amount of wiring as possible. Otherwise, it'll increase resistance, which can also add to heat dissipation. Now, down here is cross-sectional area. So if I increase the area, the resistance reduces. And if I decrease it, it increases the resistance. Think of your heart. If your arteries are clogged and you have it's not big enough, you can have resistance, a lot of pressure on your heart. That's why you want to have big arteries free from any kind of defects or fat or cholesterol. You have less resistance. So again here, this is, you may want to play with this to kind of see how resistance is affected. All right, now here's Ohm's law. So we're talking a bit more about Ohm's law. Let me wait for it here, and we'll put it right here. Okay, now this is Ohm's law. It says that voltage is equal to current times resistance. So if I increase the, notice how voltage and current are kind of proportional to each other. If I increase the resistance, the current goes down. If I increase the current, or if I reduce the resistance, the current goes up. They're kind of sort of inversely proportional to each other. So you may want to play with this and see if that helps you or give you some more insight. All right, so part one of the lab, we'll want to visit this place here, and this will be the basis of the lab here. So let me go ahead and slide it over here a little bit, and let's make it a little bit smaller. And let me slide this over here like so. Okay, and let me make this just a little. Honey, I'm recording right now. Can I call you back?
Okay, bye.
Okay, sorry about that. Okay, so we're going to hit begin. And what's going to happen is that you have a table here, and you'll want to fill in the table here. So first part here says wire type match from the table. So here we have nichrome. And we see that nichrome is on the table here. So you can select anything you want: silver, graphite, gold, copper, aluminum. But just make sure that it is on the table to help us check for unknowns and percent error. Okay. So let's suppose I have nichrome. So I would go ahead and type in nichrome here. Now the cross-sectional area, okay, you gotta be very careful here. So each one of these is a millimeter. So be 1, 2, 3, 4, 5, 6, 7, 8, about 8.8 millimeters. So I have this little thing up here where I'm too lazy, so I'm going to go ahead and use this. What was it again? 1, 2, 3, 4, 5, 6, 7, 8.8 millimeters. It gives me 0.00088 meters. Yeah, I like that. And let's go back to here. So then remember, pi r squared is the area of a circle. So I would put that information here. And so what we need to do now is the length of the wire. So let's go ahead. So I'm going to go ahead and click on this here. Well, actually, the length here. Okay, let's do it. Well, let me redo it again here. So here's the length here. This is 1.1, 1.2, about 1.3 meters. That would go here, and the resistance is right here. Okay, I would put that right here. Then I would do a new length, new resistance, new length, new resistance, and do it about 5 times. Okay, so get the data, change the length, and get the resistance here. So I would use a quick graph. Okay, we use a quick graph. I'm going to plot resistance versus length. Resistance will be on the y-axis. Length is on the x-axis. I want to extract the resistivity from the graph here. Okay. So here, put your slope in here. Determine what your resistivity is. Look at the table up here and determine what your resistivity is. And then go ahead and calculate percent error. Okay. All right. So this one here will be, let's see, part. Okay. So this one here will be lab 8.6, experiment A. All right. I'll have the other experiments on different YouTube videos. Okay.